everyone is always 5 minutes late.
Yeah, exactly. It's a busy world.
Well, that's my standard, so I don't blame anybody else.
It's great. All right. Well, I think we can get started, at least with some housekeeping. Hello, welcome everyone. I'm sure we'll have some more people trickling in over the next couple minutes. My name is Charlie Doobie. I'm the head of regenerative partnerships at Agrology, and it's great to see everyone here. Thanks for taking the time. Dr. Anita, we're really excited to have you. I think we're going to have a great conversation. So this is a series of webinars that we're doing, exploring different topics in agriculture and in regenerative agriculture, pressing issues with experts. And we're really excited to hold this space and really be, a facilitator for our community learning. So again, thanks for taking the time to be here. I'm going to go ahead and share my screen and we'll jump into some housekeeping and then we'll move right into the presentation. Well, so this is actually a great moment to point out, let's all mute ourselves. I'll mute. Okay. All right, I'm just going through and muting everyone. Okay. Yes, welcome to the art and science of smoke taint analysis and prediction. Can everyone see my screen? Holly, is this looking good? Yep.
Looks good, Charlie.
Excellent. So like I said, this is the first in a series of webinars we're doing. The next one will be on finding an ROI in regenerative agriculture, and that will be with Eric Morgan. To everyone who registered for this webinar, we'll be sending out the slides, and we'll also send out an invitation to the next webinar. So introduction, housekeeping. Again, please mute yourself unless you're speaking. Any questions or comments you have, please add them into the chat. We love to see the chat be a place for lively exchange. And at the end, we will have a question and answer period, and we'll try to get to everyone's questions. And in terms of writing down notes, I always think it's helpful for myself to learn things, but we will be sending out the recording and the slides. So don't feel like you need to write down everything. And with that, I will hand it off to Adam.
Thank you, Charlie. My name is Adam Koeppel, and I am the CEO and one of the founders of Agrology. And I'm really excited to be talking today with Dr. Anita Oberholster from UC Davis. We've been collaborating with her for... Oh, sorry, Dr. Anita, was that you?
No.
Oh, okay. All right, that was another noise. I'm excited to be collaborating with Dr. Anita. Again, we've been doing it for a while, and it's been a lot of fun, both because she's an excellent scientist and also a very fun person to talk to. So that makes all the interactions rewarding. And we're going to dive into today, Dr. Anita giving us some introduction to grape smoke exposure. Then I'll talk about the role that air quality data can play in understanding the risk of smoke taint. And then Dr. Anita will spend a little more time talking about mitigation strategies and ways to counter the risk of smoke taint. So I'll turn it over to Dr. Anita now to get started.
Thank you, Adam. Okay, so Charlie, you can go to the next slide. Okay, so that was actually just my intro slide, so I know why I created the slide in the first place. So obviously we're here today to talk about grape smoke exposure and all that entails. So next slide. So I like to just give a background about the science before we really delve into the specific area that we're going to talk about today, just so that everybody understands. So when we have a wildfire, you have a lot of wood burning. Now, if you look on the right, you'll see that 15 to 25% of wood is actually lignin, and that's what gives wood its structure. And if you look at the left, you can see the structure of lignin. Now, what happens when wood burns is the lignin thermally degrades and breaks down into its parts. And it releases an excessive amount of volatile phenols. Now, example of a volatile phenol is that compound there in the green square. So volatile phenol really is a ring structure with a hydroxyl group or an OH group on it. And then depending on the substitution in the ring, it would be called a different kind of volatile phenol. So this specific one, that is guaiacol. So depending on the vegetation burning, you can get different concentrations of different types of volatile phenols being released. Now, what happens is when these volatile phenols are released during a wildfire, they can get dispersed in the air, or they can absorb onto debris and ash in the air and distribute that way. Next slide. Now, if you're unlucky and you actually have a vineyard close enough to the fire that some of that fresh smoke, so volatile phenols in smoke do break down. When it's absorbed onto particulate matter, we don't really know at this point exactly how that impacts the speed of breakdown. But we know that fresh smoke, and we really define fresh smoke at this stage as less than 24 hours old, are the most risky for a grape or for a grapevine. You can click next because there's some animation there. So what happens is you'll see there's about 7 volatile phenols. There were more than that, but these 7 is what a lot of commercial labs will analyze for you. And the Australians have done a lot of research to show that these 7 do actually correlate really well with smoke taint expression in wines, because that's what happens. If you have too much volatile phenols being absorbed into your grapes, they can actually cause smoke impact or eventually a taint in the wine. And that taint is a very smoky, ashy character that is unacceptable as far as wine quality goes. So when you have these volatile phenols in the air, in a vineyard, and there is a berry on the vine, it can go into the grape. So it's not on the outside, it actually goes inside the grape. This can happen really, really quickly. And something else you should know is you have both free and bound forms. We think this is part of the defense mechanism of the plant, that it actually attaches various sugars to these volatile phenols to make them non-volatile. So now you have free forms and you have various bound forms. And to complicate this matter further, these compounds are present in grapes naturally. So you need to know, okay, for your vineyard, what is normal baseline? And that normal baseline will not only depend on the variety, it could depend on the season, because we know climate has a huge impact on biosynthesis, as well as where your vineyard is. Because I think some of what we can talk about today is normal VOCs, volatile organic compounds in the atmosphere, will be different depending on where your vineyard is. Is your vineyard close to a town, close to a highway, or at a high elevation in a hill? But whatever that normal is, that normal will never cause smoke-tainted wine. We only see smoke-tainted wine when those grapes were actually exposed to a significant amount of smoke. You really do need an excessive level above baseline before you have that issue. Next slide. So you can just press a few times. I think this 3 sugar is going to come up. Sorry, I usually have animation. One more, then we're done. Okay, go back, please. So basically, this is always the fun when somebody else forwards the slides for you. So what I'm visualizing here for you is when you have, for example, guaiacol absorbing into the grape, and we know this happens very quickly, then it can attach this enzyme that will attach 1 or 2 or 3 of various sugars to that guaiacol or to any other of the volatile phenols being absorbed. And this process, what our kinetic studies shows, can happen within hours. And it can go on for a while. So we often do intentional smoking and wait about a week before we take our samples to have like a stable, free to bound number, because that number can vary over time and isn't always consistent. We don't know what it is for a specific grape or specific situation. Something else to note, volatile phenols also absorb onto leaves. So onto your grapes and onto your leaves. It does not absorb onto the hardy parts of your vine. It doesn't overwinter. So if you had smoke exposure in 1 year, the next year, those vines would be fine so long as they don't get exposed to smoke again. Okay. Next slide. And I think I'm handing it over to Adam now.
Thank you, Dr. Anita. That's correct. And sorry for the slight pause there. I had to come off of mute because I didn't want to be making any background sounds. So I'm going to take a second here to talk about how you can actually look at and see if your grapes have been exposed to smoke in a year and what that means. So we have starting off here, we have a chart that compares the two things that we look at when we're trying to evaluate the smoke exposure of grapes. The first and the most critical thing on the left in green is the volatile organic compounds in the air. And that's, of course, the polyphenols that are causing the smoke taint. And that's the really critical thing. Unfortunately, a lot of the data sets on air quality with regard to wildfire smoke actually look at fine particles. And that's what we're seeing here in yellow. And this chart is a couple years of data from the Napa Valley. And the goal of this chart is to show you how little these two things align. So you'll see, large spikes on both charts that are completely out of alignment. And what we're seeing is the fact that there's not a significant correlation between the presence of fine particulate smoke and the VOCs that will actually cause smoke taint. And we have seen this time and again with Agrology customers all over California, where they will have smoke in their vineyard and they cannot tell if it's actually risky. And it's a really challenging thing about this problem that, there is smoke that you can see and even smell, and it turns out it's fine because it's from a distant fire. Like a couple of years ago, we had the mosquito fires up in the Sierra Nevada near Tahoe, and the smoke came all the way down into the Napa and Alexander valleys. You could see it in the air, you could taste it, but it was utterly harmless. It was just basically fine particles at that point with none of the VOCs that would actually cause smoke taint. And of course, it's challenging. Some of our customers, their vineyard crews were calling in and reporting, we see the smoke in the vineyard. It's hanging there. It's very present. And of course, our customers could go and say, once we talk to them, hey, look, it's okay. You don't have to worry about this. You do have to put on your personal protective equipment. That's a great time to use an N95 if you're out in the fields, but it's not actually going to damage the crop. And that's really important. And so recently, next slide, please. We've been working with Dr. Anita to understand more about the thresholds for smoke taint damage, because seeing a VOC spike doesn't necessarily mean that damage has occurred. And so this year we worked with Dr. Anita to really record the measurements of risky smoke around Agrology sensors and other sensors to see what those thresholds are. And so you can see here the experimental setup. And actually, Dr. Anita, if you wouldn't mind explaining this since it was your setup, I would hugely appreciate it.
Sure. So this is actually, we just built a tent, polypropylene piping, polyethylene, thick construction plastic. We seal it to make sure there's nothing inside. We actually have 2 electrical smokers on both sides. We don't do open fire because then we need very special permission to do these experiments, but electrical smokers gets us around that. We actually burn hickory pellets at a very set. We know we use 200 grams of pellets per hour. And we have 2 smokers, so one on the other side that you can't see and one on this side. Then it gets pumped into the middle of the tent on both sides. And then we have industrial fans actually fanning it out to both sides of the tent so that we can get a more homogeneous spread immediately within. And so we will often use this setup when we smoke grapes after picking them. Especially for our threshold wines, this is the setup we use to smoke grapes. And so we know in these kind of situations, if I put grapes in there, they are heavily tainted.
Yeah, and that was exactly the goal of this collaboration, was to recreate the smoke that will heavily taint grapes inside the tent so that we could go and look at what the data looked like. And so now if we could go to the next slide, please. This is what the Agrology sensors recorded. So this is essentially risky smoke. And we can see the sensors fire up on the left and they get themselves kind of calibrated to background levels. And then right around what says 1300 or 1310, we see this enormous spike as the smoking begins. And that spike is, clearly indicative of risk. We typically don't see spikes like this in the field frequently or at all. But also we see the sustained elevation above this 2 milligrams per meter cubed level that is, again, indicative of risk. Recently, Agrology has been working on better calibrating our sensors to pick up this specific VOC signature, ensure that our sensors aren't getting affected by any other things like temperature or humidity that could traditionally affect the readings. And as a result of this, we've really been able, with that improvement and with this experimentation, to zero in on elevated VOC levels in vineyards and help customers understand if they're above or below this 2 milligram per meter cube threshold that is what we picked up in this experiment. And that's super important. The one thing I'll highlight here, though, is that we're taking extremely frequent data. I think we're taking data maybe once every minute. And in the field, that's actually not really practical because of the power consumption. So the next slide shows what you'd actually see in a production system where we have high levels starting out with readings every 30 minutes or so, and what a risky curve would look like. So it's going to be a lot less dramatic than that. But even just seeing this period here of elevation above 2, and starting out at 3.3, dropping down to 2 range and rising again, this is cause for concern. So this is much more reflective of what we actually see for our customers in a smoke event and what we expect to see. So now on the next slide, I'm going to take a second to talk about what you can actually do with this data. So first off, I'll highlight that the Agrology system includes the mobile application, and the mobile application includes a fire warning feature, which is really critical because it's very hard to say when smoke descends into a vineyard at first, where does it come from? And knowing the distance from the source of the fire is really important in understanding if there's risk. And so Agrology uses data feeds from satellites to detect where fires are. And so we can warn our customers and actually anyone who downloads the app, even if they're not yet an Agrology customer, if there are fires nearby, so they can be on the lookout for fresh wildfire smoke that could cause problems. And so that's the first thing I'll highlight here, and that's what's showing animated in this image here. But additionally, I want to talk about how one of or a couple of Agrology customers have actually used the app and the system and the device we deploy to handle the smoke risk they've faced. So one customer used the devices and the data streams from it to learn just the natural air quality circulation around their vineyards. And they realized where there were pockets that were driven by terrain, and typically these were low points, very similar to the low points you'd see kind of inversion happening, where smoke could get trapped for a lengthy period. And that smoke being trapped in those areas would dramatically increase the likelihood of those grapes being affected by smoke taint. And so this customer went and they started prioritizing those blocks for harvest, because of course during harvest time, it's one of the driest parts of the years, there's a high risk of smoke taint, and a nearby wildfire can affect grapes very quickly. So just harvesting those grapes first is a great way to reduce risk. Even in a year when you haven't seen any smoke, it's just a way to understand a vineyard better and prioritize harvesting decisions to reduce risk. Another customer, like I mentioned earlier, they use the system to understand when their vineyard crews were reporting seeing smoke in the vineyard, whether or not they actually had to be worried at all. And that was pretty critical, because when you have your crews out there saying there's smoke and you're worried about losing an entire crop, knowing very quickly that it's actually not a risk and that you can harvest and you don't have to worry is extremely anxiety reducing and lets everyone make better decisions about harvesting and processing. Then finally, we had a customer where we actually saw elevated VOC levels and elevated PM levels and smoke observed in the vineyard. And we'd actually notified them about all of the vineyards that are affected. They were only aware of one of their properties that had an effect. And so we encouraged them to take baseline samples immediately to grab grape samples. And I know Dr. Anita will talk about that later, to do some initial testing. Then once we told them the smoke was clear, they could come in and they could do follow-up grape samples. So we could compare before and after to see if smoke taint had occurred. And it was really critical to capture those samples, because the challenge is at the end of the season, if you just pull a few grapes, you won't necessarily know if from those results if there's smoke taint, especially because some of these vineyards, due to the surrounding air quality and the grape varietal and who knows what else, just have naturally higher levels of polyphenols in the grapes. And of course, we have to remember VOCs are part of what make wine taste good. So you can't just assume that the presence of even these risky compounds is bad. And so what they did after we guided them to take a final sample was we saw that the concentrations of the risky compounds had decreased, So they weren't affected, even though they did have some risky wildfire smoke. And then we continued to monitor all their vineyards to the end of the year. We could give them the all clear for harvest, and they could harvest normally and not worry about any blocks that could be risky. Whereas if they just based it on their observations, they probably would have had to change their harvest and their processing, even discard some of their crop. So, the key thing here is that the data really lets vineyard managers and wineries and everyone involved in the value chain make better decision that's data backed. And that's really critical. And it's about both having the real-time data that comes in that lets you see all of these things that correlate to smoke time risks, but also the archival data. And the thing that's great about having archival data, what some of our customers now call a data library, is that they can compare year over year and see, last year, this is what the air quality looked like, and my grapes were fine. And this year, it's basically the same. So there's a high confidence in the grapes being fine again. And that's something that some of our customers even share out when they're serving in a role as contract growers to the wineries that are purchasing there, just to build confidence in the quality of their harvest. And so the data itself becomes part of the product of the harvest and can ensure the value of those grapes, even in a year when there is more smoke around. And I think that's excellent. So that kind of covers everything on this slide here. Can we go to the next slide, please? So the other thing I'll highlight here is that the Agrology Sentinel system, it does more than, of course, smoke risk. It's a really critical feature, but we built this to help growers with all of the climate change type threats that are affecting wine grape growing today. So smoke is huge. We've also helped customers eliminate the risk of both extreme heat events and frost by predicting at a block level where they were going to be most stressed. And so we can encourage them. Often in both cases, they're using sprinklers to handle that event, but to do it in a very targeted way where they're conserving their water resources and avoiding elevated disease risk. And of course, conserving those water resources is a really important thing so you can maintain healthy crop in a drought year when you're more exposed to fires as well. And so all of this happens in addition to the, of course, the enhanced operational efficiency that comes from having these devices tracking ground truth data throughout the vineyard and delivering really precise 3 to 4 day predictions that are highly actionable. And via the mobile application that also covers all the alerting they need so that customers can know if there's fires nearby, when there's going to be extreme temperatures, when they need to irrigate, and all these climate change exacerbated challenges. And I think this is our last slide, Charlie. Yes, so I'm going to turn it back over to Dr. Anita now to talk about some of the opportunities to mitigate risk.
Hi, yes, I was asked to just discuss quickly any mitigation action that can be taken in the vineyard. So there's studies out there that have showed that, there are changes in risk depending on the ripeness level of the grapes. And yes, the higher risk is definitely from variation onwards. But I want to accentuate the fact that there's a risk even at pea size. So long as you have a grape on the vine, there is a risk. Australia have shown where they have wildfire, it's usually much earlier in the growing season, that even vineyards that had got decent amount of smoke at pea size actually developed made wine that was smoke impacted. So you really always need to be concerned if you had any kind of fresh smoke with a decent amount of VOCs in it, if you had a grape on the vine. Now, things like washing grapes don't help. Like I mentioned, these compounds don't sit on the outside, they're actually inside of berries. And there's researchers that looked at washing grapes, even using organic solvents, and it really didn't help. Now, what about the ash? People ask me about the ash. The fact is, we've done some experiments, and it's true that that ash for up to a week can release some volatile phenols that's been absorbed onto it. But the amount that it releases seems to be so low that it really does not impact the amount of volatile phenols that's in the grape itself. If it's clear conditions and you have a little bit of ash that's releasing those volatile phenols, the levels are so low, it's not really having a concentration gradient that goes into the leaves in the grapes themselves. If you try and wash off ash in a vineyard, it's very difficult to do. Many times you just force it into the bunch. And actually wet ash gives off more volatile phenols than dry ash. So I don't think you win much through that action. Something to remember, a lot of volatile phenols are being absorbed by those leaves. So during a smoke event, if you have a huge canopy, those leaves are almost like scrubbers of VOCs. they absorb a lot of the leaves. So it does mean that if you do machine harvesting or any kind of harvesting, you want to remove those leaves before you do any grape processing, because those leaves, if they're included in your fermentation, volatile phenols will extract from those leaves. We also recommend hand harvest, and I know that's for many impossible. If you've had smoke exposure and you think you are at risk, specifically for whites, reds, if you're going to make a red wine, you're going to have skin contact in any case. For whites, you can limit skin contact a lot and actually avoid a lot of the volatile phenols that a lot of them are in the skins that will extract if you can do hand harvest, because we know machine harvesting, you get more damage of the fruit, you're going to get more extraction from the skin into the juice by the time it actually gets to the winery. Next slide. Berry sprays. So we've been looking at berry sprays, and actually that's what I was doing this morning in the vineyard, and I have to go back and do some more. So there's a few studies out there. First, I want to talk about kaolin. So kaolin is what we generally know as surround here. It's used for various reasons. One of them is a sunscreen. The Australians did a study on Merlot, Sauvignon Blanc, and Chardonnay, and they actually only found efficacy on the Merlot. And they think the reason why they only found efficacy in one is the canopy structure of the Merlot was such that they actually got better coverage in the Merlot than the other varieties. Because under vineyard condition, their best estimate was that you get about 30 to 40% coverage. And I think that's pretty accurate. We've done our own studies, and that photo is actually where I'm doing various studies at the moment here in Tyree and Davis. And in our studies, we found that we only got a small reduction of volatile phenol absorption under field conditions applying kaolin. Then there's the Australian and the Canadians looked at a biofilm called Parka, something that's used to prevent cracking in cranberries. And their initial study showed massive reduction of volatile phenols in Pinot Noir. When they repeated this study, it showed very little efficacy. And I do want to warn you, both myself and the Australian Research Institute investigated Parka, and under our conditions, applying Parka resulted in more volatile phenol absorption. We don't really know why. We think timing of application is part of it. We know that whatever you apply needs to be bone dry, needs to be dry before it gets exposed to smoke. Potentially it's because if you have something wet on the berry, it increases the surface area of the berry, allowing more to absorb. Or if you have a liquid, it's many times it has a base of water or an oil that it's almost like a conduit into the berry. So for the same reason, we do not recommend applying any fungicides or pesticides. Many of them use oils as stickers under smoky conditions. You don't want to apply anything under smoky conditions because it could potentially increase the absorption of volatile phenols into your grapes. We're also looking at EMP polymer spray called GM3E. It shows very similar efficacy to kaolin under our field conditions. A decreasing trend, it's about a 10% decreasing trend, not significant. Last year, we did a lot of variables. So we could only have like 3 vines per treatment. And there's a lot of variability among vines. So this year, we're cutting down on our number of treatments. So we can actually do almost a greenhouse per treatment. So we can have much larger applications, that it's more commercial-like. We can use a tractor to do it, where we did a backpack last time. And as you can see it's in greenhouses. Why are we doing it in greenhouses? Because what we do is we apply these sprays. We're waiting 21 days because we have found now that at least GM3 and kaolin, if you have no precipitation, they don't break down. They stay there for at least 21 days. We close those greenhouses in and we smoke them for 10 hours. And then we open it up so they can grow normally, not under plastic conditions where it will impact humidity and temperature. And then we will harvest them at ripeness. For us, that's around 25 grapes. So I just want to say, Do not apply anything under smoky conditions. If you do want to apply something, don't think, oh, it can't make it worse. There are actually products that can make it worse, especially if it's something that doesn't dry, especially if it is something that has a lot of oils in it. Whatever you apply, it's preventative. It's something you do in case there are smoky conditions somewhere in the future. Here's the other issue we currently have. We currently believe that you need to remove the barrier spray before you can process those grapes. It looks like the barrier sprays is actually just sitting on the outside of the berry. And instead of the volatile phenols moving into the barrier, wherever there is something actually being a barrier, it's absorbing on the barrier itself. So it's absorbing on the GM3E, or it's absorbing onto the kaolin, the clay itself. So if that clay is still there when you're processing grapes, it's actually desorbing from the clay into your ferment. So that's what we currently believe. We are going to go, we made wines last year where we washed and did not wash grapes. I don't have the data yet. We're currently analyzing that. This year, we're going to do much larger trials. So we are also going to do sensory analysis on these wines. So we can tell you if there's any kind of sensory impact, even if the impact seems pretty low in the vineyard itself. Next slide. So what are our current recommendations? So our current recommendations is to take samples. Adam was mentioning this as well, to take a baseline sample. So your best sample for baseline is still the one closest to harvest, because volatile phenol amounts actually, it seems to vary during the season. I'm currently my third season sampling some vineyards from variation unto harvest to see what's going on. Can you take a variation sample and be representative of harvest? The data I looked at so far, it looks like it varies a little bit during the season. So your best one that will reflect what's in the wine is really the one closest to harvest. However, because wildfire and smoke risk increases significantly from variation onwards, if you can and you have a freezer, take samples from variation every couple of weeks, throw it in a freezer. If there's a smoke event and you can't actually get out there and take a sample before your grapes were exposed to smoke, at least you can go back to the latest sample that you took that's in your freezer, so that you have something that is before and after smoke exposure. It's really important so that you can see, because like Adam said, there are outliers. You know, we're working on baseline for the main varieties in California so that we can tell you, okay, that is what's an average normal baseline for grapes. But depending on where your vineyard is, you could have somewhat different levels. So the best baseline is still the one you have for your own vineyard blocks. Do take a representative sample. The larger the sample you can take, the more representative. You want to have it representative of your block. Do not just take of the few vines that you think were the closest to the smoke. You can do that for your own personal evaluation if you want to take something close and something further away to see if there's a difference. But for crop insurance, for instance, you need something that's representative of the whole block. And you only need 300 berries. But the problem is, I like to do cluster sampling. I go inside, outside the canopy, and I go every few vines. I cover the whole block. I destem it all really roughly, and I get a very representative sample. One part I give to the lab to analyze. The rest I keep in my freezer for reference. Keep a reference sample. I have so many people that now wish they could go back to some samples because there's some litigation or some question about the analysis. Also, what kind of analysis do you need to do? As extensive as you can. Please do both free and bound. Extensive panels. I know currently for crop insurance, you only need 3-glycol and 3,4-methyl-glycol. But we know that most of it could actually be in the bound form, and your grapes may show very little free and have excessive amounts of bound. You have to care about that bound form that's bound to glycosides, because during winemaking, 20 to 30% of that will get released during winemaking. And when you taste wine, most people have bacterial enzymes in their saliva that can actually hydrolyze those bound and release it. And we know we think it's that action combined with a free that's really giving you that ashtray, what we call an aftertaste. It's really a retronasal aroma character that you get by mouth. So it's very important. You can get free and total. Some labs do free and total, or you can get free and individual bound. I do recommend go to one lab and stick to one lab. Different methods give you different values. It's not the same value, although they should correlate with each other. So you don't want to jump around with different labs because you may get slightly different numbers and then you can't compare your data with each other. So just stick with one. And this is also why we recommend bucket fermentations, especially if you think your grapes were exposed to smoke and your free numbers comes back as non-impacted. I would suggest doing a small fermentation and seeing if you send that fermentation, that wine to the lab, if you get higher free numbers, because during that fermentation, like I said, 25 to 30% of the bound will get released to free, and that number may actually give you the protection you need. Crop insurance will allow you to use that wine number if you can show chain of custody, meaning you can show that that wine represents a specific vineyard block and wasn't mixed with anything else. Okay, next slide. So I was asked to talk a little bit about future plans. So, currently, sensor network. We're trying to have sensors in as many places as possible. Currently, it's mostly Napa, Sonoma, and this is part of my research project. Napa, Sonoma, and we're trying to add Lake County now. So that we can, because the more data we can get, the better. We want to see baseline for these areas. Baseline, what is the particulate matter changes over time? What is baseline VOCs? If there is a smoke event, how does the particulate matter and the VOCs change? Is there during a period, during a wildfire, if smoke is really fresh, there's some correlation between particulate matter and VOCs? We don't know. We do know that they separate from each other definitely after a few hours, just because particulate matter hang around for a long time, where volatile organic compounds actually can break down within hours, depending on whether it absorbs onto debris or not in the air. So the more data we can get, the better modeling and prediction we can do. We're also, all the sites where we have a sensor network, we're taking air samples and we're taking grape samples and making wine from those samples, relating grape and wine data to the VOC data and the particulate matter data to see what's the most important things to measure and what levels of VOCs, what levels of particulate matter, if it's going to show any kind of correlation, do we actually start getting risk of smoke taint? The more data we have, the better prediction we can do. We're also working on baseline. We're currently focusing on the 7 main varieties in California. Washington State and Oregon State is also doing baseline. We're doing Sauvignon Blanc, Chardonnay, Pinot Noir, Syrah, Zinfandel, Merlot, and Cabernet Sauvignon. We're doing our 3rd year this year, and we hope next year to have a general baseline data out there for everybody to use if they don't have their own baseline, so they can compare their lab results better with baseline and interpret the results more easily. I just described that we're continuing with our berry spray studies, and if there's any new berry sprays that come out, we will evaluate to see if there's anything out there that will be beneficial to apply in the vineyard. It will not be a silver bullet, whatever you spray in a vineyard, because of coverage. You can never get 100% coverage of that grape bunch, so will never be able to give it 100% protection. Then we're also working on the wine side. When we smoke wines, we do serial dilutions of wines with their controls that won't smoke. We are trying to figure out what are the sensory threshold levels for quality impact due to volatile phenols. We know the wine matrix has an impact. Everything else in the wine actually impacts smoke taint perception. So we need to work out in different wine matrices, okay, this is normal and this is too much. And there will be a gray area in between. So I call it the 2 big ends. So if we have baseline data, and we have threshold data for different wine matrices, it will make it easier to make winemaking decisions based on grape and wine data. And then we're working on amelioration treatments. This is after everything you've done the best you can, unfortunately, months later, that wine still developed a low level of smoke taint. What do we do now? Is there something we can do to fix? The current fixes that we have to remove smoke taint, unfortunately, is not very specific. So they also remove other compounds that's beneficial to the quality of the wine. And even though they may remove the taint, they also decrease the overall quality of the wine by removing body, aromas, as well as color from red wines. So we're working on techniques that will be way more targeted. So you only remove the compounds that's problematic. And remember, you only need to remove as much as is causing smoke taint. You don't have to remove everything because these compounds are naturally present in grapes and wine. It's just at an excessive level where they're problematic. Next slide. Okay, so it's question and answer time.
Yeah, so it looks like our first question is, can the sensors distinguish between total VOCs and these volatile phenols?
That's a great question. And at the moment, we're working to calibrate these sensors against the target species of VOC, the phenols, to the best we can. And so the first step was removing the effect of any kind of background influence of humidity or there are compounds. And so that's something we achieved, and we're upgrading all of our customers this year. But ultimately, one thing that I'll emphasize with the way Agrology offers its products and capabilities is that our customers actually don't own the hardware. And that's really important because what it means is that the hardware is leased and rented. And as soon as better capabilities exist, we upgrade our customers. So we are developing sensors that we can target against the exact smoke taint risk compounds. And as soon as we have them ready, we'll go and upgrade our customers. What we have seen is that they are really good at picking up two things: the presence of VOCs from smoke, and also occasionally the effects of spraying. And so it's very easy to determine quickly if it's a spray event or if it's a smoke risk event. And we do that by, of course, asking if sprayings happen, and then also taking a look at PM levels and also the length of the duration. So we found really good ability to distinguish the kind of risky events that we want to, even with the first generation sensors we put out. And that's only been improving every year as we better calibrate them against the threat and as we evolve all the systems for our customers towards targeting to the specific gases of interest.
Yeah, and part of the research we're doing is because VOC sensors do capture more than just the volatile organic compounds, is that's why we take air samples as well. So the air samples we take is we actually have tubes where we absorb the volatile phenols. We have a pump, we pull it through a 10x tube, it absorbs the volatile phenols, come to the lab, and we desorb it onto GCMS. So we can see, how the VOC sensor relates to the volatile organic compounds we're actually measuring in the air. What I can tell you is when we do intentional smoking, we do the same thing. Is with intentional smoking, because you're releasing so much volatile phenols, a lot of that increase in VOCs that you're seeing, that correlates actually with the increase in volatile phenols. And so that is important, and that's good. Because it's showing that that increase can give you an indication of volatile phenol increase as well. But we need, the longer we do this and the more sites we do it for, the better we can figure out what those correlations are.
Awesome. Great answer. The second question is, what kind of chain of custody documentation would crop insurance require for these bucket fermentations that you were referring to?
I'm not actually sure. I just know that you need to be able to show that the bucket fermentation just came from one vineyard block, because they need data per variety, per vineyard block. And why that's really important is they're always concerned when grapes go to a winery, for instance. They just need to show that lot of grapes went into that fermentation tank. So if you do it at home, I don't think you need I mean, somebody needs to check. As far as I know, so long as you can document and show that this block went into this little ferment, you're good. It's more like in a winery setup, they need to show that only that one block of fruit went into that fermenter.
Awesome. I had a question for you, Dr. Anita. You got me thinking when you were talking about how sometimes with these sprays, they actually make them worse because there is some moisture on the edge of the grapes. And I was wondering, have you seen any difference in how volatile phenols are absorbed when the vines are recently irrigated versus bone dry? Is there a difference in terms of the actual, moisture in a vineyard?
That's an interesting question, and I don't know. So we actually haven't done studies where we, we haven't done comparison of vines under different stem water potentials, which is basically what that would be.
Mm-hmm.
I know in Australia, Kerry Wilkinson did a study where they actually used hedge sprinklers, but that was to see if it will help or decrease the smoke in those conditions, and it didn't have a large impact.
Mm-hmm.
It didn't make it worse or really that much better. So we don't actually know. That is an interesting question, because what we usually do, if there's a risk of fire, most people that have the availability would open the water, would open the taps and make sure that their vines are well watered. Now, the vines that we smoke, we usually make sure, because when we put them in those tents, they do experience severe stress conditions. So our vines are usually pretty, non-stressed before we do that. So I don't know. I actually don't know. That's a very interesting question.
Well, maybe we'll have to make a new study.
Yeah, another one.
Yeah, just another one. You didn't have enough. Awesome. Well, are there any more questions out there? I only see the 2 in the chat. Feel free to unmute yourself too, if you'd like to just jump in and ask your question directly, but this is your chance. Going once, going twice, see if anyone gets brave at the last minute. All right. Well, with that, I think we can kind of begin to wrap it up. I don't know if you have any kind of conclusion comments, either you, Adam, or Dr. Anita.
Yeah, sure. I'd like to say thank you, everybody, for attending real quick. I'd like to remind them that if you're worried about wildfires popping up near your vineyards, please feel free to download the Agrology Fire Map app, which will give you a heads up about any fires that are starting nearby and help you figure out if any smoke you see is related to that fire, or if it could be something more distant. It also give you an idea of what the capabilities of Agrology's system are without investing anything. Or feel free to reach out to us and talk. So thank you for your time today. Dr. Anita?
Oh, thank you. Yes, and you'll see that we have on the Viticulture and Enology website at UC Davis, we actually have a web page focused on wildfire and smoke exposure resources that we try and update. It has a list of the labs that we know of. We will see now in 2023 if there's any additional labs that do volatile phenol analysis, and resources from various places, from ourselves, from other universities here in the US and in the rest of the world. So you can go and check out that page just to be up to date with what we know and what you can do regarding smoke risk. And thank you for listening to me and for your time.
Awesome. Thank you so much. I'm going to end my screen share. Yeah, Dr. Anita, thank you so much for joining us. We really appreciate it. Everyone else, thanks for joining. Thanks for your time. We will send out the recording as well as the slides. And stay tuned for future webinars. I think we have one in about a month with Braga Fresh's head of sustainability, and he will be exploring how to get ROI in regenerative production systems. So that one should be exciting. But yeah, again, thanks everyone for their time, and we'll see you next time.
Thank you. Goodbye, everyone.
Thanks, everyone.
Thanks, Anita.